We're going to determine the molecular formula for limonene from its percent compositions, and we have its molar mass. So the first step is to use these percents to get grams, to get mass. So what I do is I assume I have 100 grams of this limonene, and then that means that in that sample size I have 88.2 grams of carbon and 11.8 grams of hydrogen. But we know we can't have a chemical formula that is like this. Partly because those have to be whole numbers, but also we know that these numbers have to be in terms of a number of particles, not mass. So we can't use this, but what we can do is convert these to a number of particles, and in chemistry we use moles to represent a number of molecules. And so I'm going to use a lot of digits to go from grams to moles. I use a molar mass. Or right off the periodic table. I'm going to use a lot of digits for mine. It just makes the numbers come out a little bit easier to see. Sig figs don't really matter in this because we know in the end we're going to come up with whole numbers. I'm going to come up with whole numbers for x and y. And if they don't come out to quite whole numbers, it's because of error that is present in these percents and also in our molar masses. So we want to try to keep some extra digits. Okay, and so once I convert to moles, I look at my numbers, and they're not whole numbers, but my next trick is that I divide these by the smaller of the two. So the smaller of the two is the 7, so I'm going to divide them both by the 7.34. And this gives me, of course, 1 here. But here, it doesn't give me a whole number. And so I would be good with my x. It would be a 1. But my subscript on the hydrogen would not be a whole number. So the next trick to get it to a whole number is to multiply both of these by a factor so that they both are whole numbers. So in other words, this one's the problem one. What number do I multiply that by to get a whole number? And if it's not easy to spot right away, because you know, if it's something like 1.5, then you can just say, oh, I'm going to multiply that by 2. But if it's something like this that's harder to spot, you might just put this number in your calculator and try times 2. No, not a whole number. Times 3. No, not a whole number. And keep going until you find on this one, if you multiply by 5, it comes out very close to 8. So we have to, if we want to keep the same ratio, I need to multiply both of these by 5. So it's a 5 to 8 ratio. So our empirical formula, I'll put it down here, is going to be C5H8. Okay, but it asks for a molecular formula, so we're going to do that other step to get to the molecular formula. So, and basically what we need to do is see how many of these we need to get to. We're going to multiply by some n in order to get to a molar mass of 136 that was given. And so I need to see what the molar mass of our empirical formula is. And then again, I want to see how many of these it takes to get to that. And that one you could probably just eyeball and know. But if you're not sure, basically what you do is you take the molar mass of the whole compound divided by the molar mass of the empirical, and you get 2. So 2 is that N to get to the empirical formula. I did that backwards. I'm going to multiply it by 2 to get to the molecular. And so basically I'm going to go from that and that is our molecular formula.